So the topic for today is adding and subtracting rational expressions. And the process for doing this is actually just like adding and subtracting regular numerical fractions. The key to this is you have to have a common denominator. And that is oftentimes the most difficult part about this process, is getting a common denominator. So let's quickly go through the steps, which you'll recall are follow very much how you add and subtract regular fractions. So first of all, you have to find the LCD, which is the lowest common denominator. Now, I will give you a hint. If you have a binomial or a trinomial in the denominator and it factors, factoring it first will help you do this. All right? So a lot of times your first step is going to be to factor. Next, rewrite each fraction with the lowest common denominator as the denominator. And I'll show you how to do that. Then you're going to add or subtract across the numerator. This often means that you either have to distribute or FOIL in your numerator. All right? Next, keep the lowest common denominator as your denominator. After you do that, you are down to one fraction. So you've completed the process. The last step is to simplify it if you can. So in other words, that means anything that's not factored, factor it and see if any factors will cancel. So we're going to start out on this page with some relatively easy examples. Now, if you recall, if we do something like add a third and a half, we need a common denominator. And remember, our common denominator to add a third and a half would be 6, right? Notice something about this. The 6 is bigger than the 3. The 6 is bigger than the 2. When you're finding your lowest common denominator, when you're doing the addition and subtraction of rational expressions, your lowest common denominator is going to be bigger than the denominators of the individual fractions, not smaller. Because sometimes people confuse finding the greatest common factor with the lowest common denominator. Two completely different things. So here's what I have to do. If I go to example A, I've got to find the smallest expression that all three of these denominators divide into. All right? Keep in mind, it's going to be bigger than either of these three. So first of all, I'm going to go to my numbers. I've got a 6 and a 3. What's the greatest common or lowest common denominator between a 6 and a 3? Well, that's 6, all right? So we're starting to identify our lowest common denominator. And I always write it down when I do one of these problems. Now, if I look at just the A's, I've got an A squared, nothing, and an A. Now, I need to take the largest power of A. All right? So that happens to be A squared. I need to take the largest power because I need the largest power in order for this A squared to divide into it. I can't just take an A because A squared here won't divide into it. Now, if I look at the B's, I've got none, B squared, and B. Take the largest power of the B's, and that happens to be B squared. So my lowest common denominator is 6A squared B squared. All right, my next step is I'm going to get out my red pen here and write things in. Let me go over here to the side and just do the simple 1/2 plus 1/3. And we said the lowest common denominator was 6. And so here's what we did to get the denominator of 6. We multiplied here by 3 on the top and bottom, and here by 2 on the top and bottom. Right? You remember doing that long ago? That's exactly what we're going to do here. We're going to go to this problem, and the question is, what do I need to multiply by to make this denominator the same as the lowest common denominator? And the answer to that is a B squared. I need a B squared. So I'm going to multiply by B squared on the bottom and on the top. Now here, what do I need to multiply this by in order to get it to be 6a squared b squared? Well, I need to multiply by a 2 and an a squared. So I'm going to do that on the bottom and on the top. All right? My next fraction, I just have ab. So what do I need to multiply by to get it to be 6a squared b squared? Is 6ab. So I'm going to multiply that on the bottom and the top. All right, now all three of my denominators are the same thing. So my answer is going to have that denominator, which is 6a squared b squared. All right, my numerator, I'm just going to add and subtract right across. So I've got b squared plus 2a squared minus 6ab. My last step is to factor this if possible and cancel. Now the only way anything's going to cancel is if I can factor out a GCF from here, but I can't. All right, there's nothing common to all three of these terms. So this is it. I cannot simplify that. All right, that's the basic process that we go through to add and subtract fractions. So it's a little bit more work than multiplying and dividing. All right, let's go to the next one. So we've got example B here. And first thing I need to do is figure out my LCD, my lowest common denominator. So I have an 8 and a 6 and a 2. And what they all divide into? 24. All right, so 24. Then I look at just my A's. My highest power of A is A squared. So I've got A squared. And my highest power of B's is B squared. So there's a B squared. All right, next I'm going to need to rewrite each of these fractions so that my denominators are the same. And that's what I did up here in the red. That's what we're going to do. So first of all, this first denominator, in order to get it to be 24a squared b squared, I need to multiply by 3a squared. So I'm going to do that on the bottom and on the top. You know what? Go back here for a sec. I just saw my mistake. See right here? 6 times 2. I didn't finish multiplying. Over here, this shouldn't be 6ab, but 12ab. Sorry about that. Sorry on the video. All right, let's go back to this problem. 6a squared, what do I need to multiply it by to get it to be 24a squared b squared? How about 4b squared? So, get my red pen out here, times 4b squared on the top and the bottom. And lastly, 2ab needs to get multiplied by 12ab. So multiply by 12ab on the bottom and on the top. Now, all three of my denominators are the same. So my answer is going to keep that denominator, 24a squared b squared. And I'm just going to add and subtract across. So here I've got 9a squared. Here I've got plus 4b squared. And here I've got minus 12ab. All right? Now, this may or may not factor. If I wanted to try and factor it, can you see that it's not in a good order for that? You would change it to something like this. How about this? 9a squared minus 12ab plus 4b squared. Now you can see if this factors. This 3a and 3a, 2b and 2b, the middle 3a times 2b times 2 is negative 12. So it does factor. In fact, it would factor into, tell me if I'm right, 3a minus 2b quantity squared. But you don't have to do it. Here's why. Still can't cancel anything. All right? The only way I could have canceled is if I could have factored out a GCF. But I couldn't. So you don't have to factor in this instance. All right. Let's go ahead to C. Now what you're going to notice with this one, first of all, it's a little different because we have a binomial in the denominator. But notice, that binomial is the same. We have a common denominator. I put this in here for a reason. And the reason is so you can see what we do to the numerator. So, my lowest common denominator is x plus 2, but already my denominator is x plus 2, so I don't need to get a common denominator. So nice and easy here. My answer is going to have the denominator x plus 2. Here's what I've got to do. I've got to subtract across my numerator. And what that means is because I've got a minus sign right here, I need to put this in parentheses and distribute that negative when I subtract. All right? So when I subtract, I've got 3x squared minus 8, then minus x squared, and negative times negative is plus 9. All right? My next step, I've got to simplify that numerator. I'm not done yet. I've got to simplify that. So let's combine like terms. I've got 3x squared minus an x squared. That's going to give me 2x squared. And a negative 8 and a positive 9 gives me plus 1. And this is over x plus 2. Now, my next step is to look and see, does this factor? Can I factor anything out of this? And this numerator does not factor. So there's nothing I'm going to be able to cancel unless something factors. So I'm done. All right, let's go to the next page. All right, my first step here is to ask myself if any of my numerators factor. And here's the fact, x squared plus 1, this doesn't factor. X clearly doesn't factor. Guess what I have to have as my LCD? All right, I need to come up with something that this will divide into and this will divide into. So my LCD is actually this, x times x squared plus 1. So here's what I've got to do. I've got to change my denominators. In order to make this denominator the same as my LCD, I need to multiply the top and bottom by x. So there we go. I've multiplied by x. My next step here, in order to make this denominator the same as my LCD, I have to multiply by x squared plus 1. Do the same thing on top. Okay, now I have a common denominator. That common denominator is x squared plus 1. Now my numerator, I'm just going to add across, but notice I'm going to have to distribute as I go. All right, so I've got 2x plus 5x squared plus 5. Now the interesting thing is here is I want to factor this to see if anything's going to cancel. If I was going to do that, here's what it would look like. I got to put it in the right order. It would be 5x squared plus 2x plus 5. Here's the issue with that. If this factors, and I would need to use the box method to find out, if it factors, it's going to factor to an x plus and an x plus. I don't have an x plus in the denominator. So it's not necessary in this case to factor, because even if I do, nothing is going to cancel. so I can move on. All right, my next problem. Here's an example where it's so beneficial to factor the denominators. All right, so I'm going to write this out, factor, and notice I'm going to leave a lot of room, and I'm going to do that because I know my next step is going to be to do that multiplying in red. So here's what I've got. I've got 3 over. What multiplies to -6 and adds to 1? How about +3 and -2? So this will be x plus 3, x minus 2. Leave a little room. And we'll write in my next fraction. It has 2 in the numerator. What multiplies to +2 and adds to -3? How about -2 and -1? All right, here's what we have. We have a number of different factors in our denominator. We want to take the highest power of each individual factor as our LCD. So let's look at our denominators. We have an x plus 3. We're going to need an x plus 3 in our LCD. We have an x plus 2. We're going to need an x plus 2, or I'm sorry, x minus 2 in our LCD. Now, if you notice, this one also has an x minus 2. We don't need to have 2 of them here. We only need to have 1 because each of these has 1. So the highest number of x minus 2s is 1 of them. So I only need 1 in my LCD. And then here I've got an x minus 1. So I need an x minus 1 in my LCD. So you'll find that sometimes your LCDs are quite long. So first of all, if we go back to that first fraction, what do I need to multiply my denominator by to get an LCD? X minus 1. So do that on the bottom. Do the same thing on top. If we look at my second fraction here, what I need on the bottom to have my LCD is an x plus 3. So multiply the bottom by x plus 3. Multiply the top by x plus 3. All right, my next step is to do my subtraction. And my answer is going to have the LCD, which is, and it doesn't matter what order you put them in, x plus 3, x minus 2, x minus 1, all 3 of those factors. Now my numerator, here's what you've got to remember. You need to distribute your way across, all right? So first of all, I've got 3x minus 3. When I distribute, notice something. I'm distributing a -2. So this is minus 2x, and then minus 6. All right, so I want to combine my like terms because I need to simplify this. So keep my common denominator. So I've got x plus 3, x minus 2, x minus 1. Here's what we're going to do. I've got 3x minus 2x is x. -3 and -6 is -9. Now, that doesn't factor, and it's not common with the denominator, so nothing is going to cancel. I know that today we haven't found anything that will cancel. On your homework, this will not necessarily be true. There will be things that will cancel. So my last example is C. And again, the very first thing we want to do, in order to find our LCD, we want to factor, okay? So I'm going to rewrite both of these fractions with their denominators factored. This one has a GCF of x. So this is x, x minus 1. This one has a numerator of 1, and this factors difference of 2 squares, x plus 1, x minus 1. Okay, I need to find my LCD. So I'm going to look at these here. First of all, I have an x. I'm going to need an x then. And I've also got an x minus 1. Now this one also has an x minus 1, but I only need one of them because I have one here and one here. And the highest number of them that any individual fraction has is just 1. So I only need one in my LCD. But I'm also going to need an x plus 1. So let's do the multiplying of our fractions now. So in this denominator, I need an x plus 1. And I'm going to need that in the numerator. All right? In this fraction, my denominator needs an x. So I'm going to put that in the numerator, x. So now I have a common denominator, and so now I can actually do my adding. So my denominator is x, x minus 1, x plus 1, and when you're adding across, make sure that you distribute. So I've got 5x plus 5, and then plus an x. So now I need to combine my like terms. So again, I've got that denominator. My numerator, 5x and x, is 6x plus 5. And it doesn't factor, and it's not common with the denominator, so there is nothing that I can cancel.